Okay, so what mistake are we going to make in this question? A spherical, that may be important, snowball has radius 12 centimeters initially. After 20 minutes, so that sounds to me like t equals 20, it's 8. In a simple model, the rate of decrease of the snowball's radius is inversely proportional to the square of the radius. Right, so the rate of decrease of what? Of the radius. If it's not obvious, the denominator is usually time. You can see here they're actually being incredibly generous to us. Okay, so dr dt is inversely proportional. So inversely proportional to the square of the radius. So there we go. So where's my mistake? Well, you could argue that there's no mistake, but it's certainly not clear here is that there's a rate of decrease. So if I'm assuming that k is a positive number, which is sometimes done in these questions, really I should have that one there as a minus sign. Okay. What should we do next? Well, this is all about differential equations, dr, dt, and r. So in order to use some of this information that I've got above, I want to be doing some, well, first of all, I'm going to need to be doing some integration because I don't have any numbers up here about how it's changing, so that's not too useful. But I do have values about radius and time. So if I separate my variables, I will get r squared dr, multiplying by r squared on both sides, equals minus k dt. I can then integrate, and if I do that, I'm going to get a third r cubed equals minus kt plus c. And this is the time that I could start to use some of my information. So I had t equals 0, r equals 12. So I could sub that one in. And what would that mean? It would mean a third of 12 cubed is going to equal my c value, for example. And then when I have my c value, what else can I do? Well, I can use the other piece of information. So I can then use the t equals 20 with the r equals 8. So in these questions, what we need to, this will give you k, by the way. So in these questions, what do we need to do? We just need to be slightly mindful that when we have something like the rate of decrease, for example, that we're taking this into account in our equations. We may have been told, for example, that k had to be positive, so decreases we would expect to see something like this. Let's do another one to practice. So a balloon is modelled as a sphere. We've got a piece of information there, and we've got, another piece of information. Let's call this t equals 6, r equals 8, because it's on a new line. A simple model assumes that the rate of increase, of what? Of the radius. Well, there's the is. So where's the other part here? So again, when it's ambiguous, it usually means that it's with respect to time, and that kind of makes sense if you think about the information that we've got in the question. So is directly proportional because I put equals. I know that there's potentially going to be a connecting number there. So this is what I would be looking for. Directly proportional, yes, but to 1 over r. So something like this. What would my steps be? Well, I'll just check the sign first of all. Rate of increase, I'm happy with that. Okay, but what I would do next is I would do the same thing again. So I would do r dr equals k dt. We would integrate. Okay, so let's just do a few of those steps very, very quickly. Kt plus c. And then usually as soon as you integrate, that's the time to start using your information. Okay, once normally with t equals 0, that will give you your c value. And then finally, you'll be able to use this information here to find your k value and get your complete equation. So the mistake Perhaps not necessarily an obvious mistake in this case here, but when we have a rate of decrease, we need to look out for when we're making our equations like this. One last one for you to read and just to have a quick think about. We're just going to write the setup for it, and I will leave you to do the rest. So the rate of decrease of the water depth. So depth is h in this question. So dh, and again, there's that dt. The rate of decrease, so we need a minus sign on this one here, okay? Equals, goes with a k. Inversely means I'm in the denominator, the square root of h. So this would be my setup. What I would do next, well, this one's slightly more confusing. So let's just have a look at the first sort of line or two. Okay, very, very common to get this. I'm sure you can think of lots of questions where you see minus k and that will integrate into minus k t. Over here, we've got h to the half equals minus k dt. Okay, so what will that be? Well, that will become h to the 3 over 2. So we'll have a 2/3. We'll have minus k, this is if we integrate it, minus kt, and then we normally put the c on the right-hand side. Okay, and we'll finish off the question just like that.